Hello everyone, welcome to the Open AGI Forum. I'm Eric Wong from CSDM, and today live from the GOSIM China 2024 in Beijing, we're honored to have Rik Arends he's founder of Makepad to join us. So he's got plenty of experience to share, so welcome Rik. Please take a brief introduction of yourself, please.
Thank you. I'm Rik Arends. I'm the founder of Makepad. Makepad is a rewrite from scratch of the UI stack in a way that how I wanted to be able to write user interfaces. I've been an entrepreneur my whole life. I've also founded Cloud9 IDE before I founded Makepad. And I've always been very interested in building high performance UI so that the hard is doable, hard applications are doable. And I found HTML to be very, very limiting. I set out to explore to find a better way, at least for my use case, which is code editors, IDEs, design tools.
I see. So you have 20 years programming experience. You're using C, C++, and JavaScript and Rust.
Yeah.
So, and how can this different language experience makes your programming philosophy, how they shaped your perspective on software development?
Oh, I think it's very, very useful to really go to the limit in a language. So I went to the limit as far as that went in 2005 with C++. I went to the limit with JavaScript. Then you go from a static compiled language, which is still quite dynamic compared to Rust. You go to JavaScript, and you now have a garbage collector, and things aren't immediately fast anymore, but you also don't have horrible memory errors anymore. So it's a completely different world, and you learn to program in a very different way. Like for instance, in C++, code generation is really quite hard. Templates are really ugly. In JavaScript, you can co-generate a lot of things at runtime. So, you can co-generate a lot of things at runtime, and so I learned a lot of meta-programming in JavaScript that was completely impossible to do with C++. So because now I have the ability to runtime generate specialized functions, right? Essentially, Rust is again sort of like a step back in certain ways, but also a massive step forward. Because you're again in a compiled language, so there's no more runtime code generation. But you do get all these nice memory safety features, high performance, access to low-level APIs that you didn't have in JavaScript, not without a lot of work, right? So essentially, every time I switched language, I learned a whole lot of new things. But also I learned that you can't take everything with you. So in Rust we don't have a garbage collector and we don't have runtime code generation, and that changes the way you program. I think for the better, because runtime code generation is of course very tricky, right?
Yeah.
Like if and with Rust, you start to learn that having a more structured, safe system is actually good for code quality. So one of my problems with C++ was that I would make memory errors, and that would crash the program unpredictably, which is really not good for your blood pressure. With JavaScript, you had unpredictable memory, so it would have too much garbage, start hiccuping in the garbage collector, and when you're doing rendering in UI, you don't want an animation to start hiccuping randomly, right? So JavaScript was very annoying. And then now with Rust, you have to live with the other constraints. But it is very stable. It makes very stable code.
Yeah, no memory problem.
No memory problem, no performance problem. Certain things that you thought were nice maybe weren't as good for productive software.
I see. So you have mentioned your excitement before about using computation for visuals and audio. So how this interest develop and how has it influenced your career path?
So when I was a very young kid, 8 years old or something, I was completely taken by the Commodore 64 and the MSX and the Amiga and these early home computers that had colors and sound, and that was the first attraction to the computer for me. The first thing I programmed was in BASIC play a Mozart tune, very, very basic, on the PC speaker. And yeah, that original excitement for computation has never left me. But I did find that every iteration it became sort of more work to get to the basic place of playing a sound or playing, and even now it is still very hard. I haven't really completed the APIs to get back to that level of simplicity. But also the times have changed, right? Right now maybe the next frontier is AI music. I don't know. Maybe the holding on to the past there is not the best way to the future. But that was how I originally started with it. And then when I was about 18 or 19 years old, I started using the first GPU, the Voodoo graphics in C++, and it was like magic to me because before if you wanted to draw something, you had to write a CPU function you call triangle fillers, right, or fillers, yes. And you had to fill polygons with the CPU, and that was very slow. And also quite hard to make it even fast enough that it was fun, right? That it was interactive. And with the first GPUs, you could render a complete 3D model with shiny surfaces and everything. And that was my second magic moment where I was like, okay, I'm just gonna do GPU accelerated graphics because that was fun. And all you needed to know was a little bit of mathematics and a little bit of matrix algebra, and then you could do it. It was just magically sharp, and yeah, from there on, I got interested in making user interfaces for design tooling for making these real-time animations. And I wasn't particularly interested in the gaming angle because that would have been another career path. I was mostly interested in user interfaces, and then I started to get into user interface UI toolkits, doing XML, but all in C++, right? And at some point I realized, this was like 2004 or something, 2005, I realized I'm building a web browser. I'm building a web browser, but it already exists, so why should I continue building a web browser? So, because I wasn't particularly good at it, I think I was better at it than I might have thought at the time, but I thought like I cannot compete with the browser, right? It's already there and it's already working. So what I did was I switched to JavaScript and web development, and that was a very painful moment because from being able to do everything in C++, I all of a sudden could do very little and everything was slow. So, but also you could make money with making web applications for companies, and so that's how I got into building UI technology. And at some point we had enough UI technology that we actually could build an IDE. And that turned into Cloud9 IDE.
I see. Yeah, the next question is exactly about the Cloud IDE. Yeah, you were involved in developing Cloud9 web-based IDE. So can you discuss the challenges and learning from developing a web IDE, especially now the AI IDE is coming out that's doing on the cloud. You know, some of them is in cloud. So what is your comments?
So as I said, we rolled into the Cloud IDE space from being fairly good at building complex user interfaces in a browser, and that was and is still very much of a challenge that a small group of people is capable of doing in HTML. And so the challenges were, on the one hand, the UI, right? How do we make a code editor that's fast enough? How do we manipulate the DOM so that the code editor doesn't feel slow? And I didn't do that particular part. We had a colleague of mine, Fabian, who built the first the code editor, the technology. We had a small company. We had a group of engineers, and but that challenge then was solved well enough that we could do it, and that was the foundation of the rest. And the rest really was a UI kit around it that was also developed by my co-founder at the time. And so I always thought that the UI challenge wasn't solved because it was just not fast enough. I couldn't do code folding and animations, and none of these things worked in HTML because it was too slow. So in my experience, the UI was a bottleneck to actually innovate, because I didn't want to do just the same thing as the other IDEs. I wanted to do new things. But the real problem was with the cloud backend. like hosting compiles with people. The cloud at the time was very, very early, so everybody just had their first cloud or something. And so that meant that we had to search for a cloud solution that worked, and that was incredibly hard. So my experience from that is that it gave me a profound dislike of cloud because of the management complexity and also the cost involved. Especially for a startup, cloud can be very, very expensive.
Yeah. So after that, or before that, how did the concept of Makepad framework comes up in your mind, and what problems does it aim to solve?
So because Cloud9 was built on HTML and CSS, I knew it very well, and I also realized that the HTML engine, I mean, at least at the time, would not be fast enough to make the kind of dynamic design applications that I had in mind, because I always wanted to fuse design and code in a usable way, right? Like have a code editor with live inline widgets, with animations, have a design tool that is all scaled up to not be a toy, right? To actually work at scale. And so I set out to because WebGL was just released, like only a couple of years before, or very version before, and I was like, what if we, because Shader Toy I think also existed, just Shader Toy is a website where people write little pixel shaders, and so I had this, I saw all these animations and shader things that were of course very inefficient to execute, but they gave me proof, like, okay, we might have a way to draw or style things that might not be based on CSS or a vector engine. Maybe we can use little programs for the styling. So then I was like, okay, well then we just use JavaScript and we use WebGL, and I tried to build my IDE again in WebGL and JavaScript, and I tried that like almost 5 times or 6 times, completely from scratch, do it again. And then it failed again for some reason. My last iteration had Makepad JavaScript using a multi-threaded architecture, so I had a display server in the main thread, and I had web workers that ran the applications that would just send over their display commands and their shader programs to the main thread. It was really, I was really very proud of it. I gave a lot of talks on it, you can also find that online. But the problem was I wanted to use that thing to make itself, right? I wanted to write Makepad Studio or whatever Makepad at the time in Makepad. And after about 30 minutes of programming, my Chrome would just crash, like you get the sad face tab. And without any hint to when or why or how. And also at the time, I had this very nice code editor working in WebGL and JavaScript. And but it was so inefficient that I was using like 100% CPU whilst you were typing, right? It was very hard to make that fast. And a friend of mine in game development, a very motivational guy, he said like, yeah, that's cool, you made a UI. For what? I was like, what for? I mean, come on, you can do anything now. It's like, yeah, but for what? You don't have any CPU time left to do any work. And that hit really home to me. I was like, okay, yeah, you're right. Like a UI often can only use a very small percentage of the CPU because the thing has to do something, right? Has to do something useful. It has to be CAD software, it has to be whatever, something that uses CPU. And I can also think, well, we do it on another thread, but that's really not what you want. So that made me essentially give up on JavaScript, because I gave it my best shot. I tried 5 or 6 times. And then my current co-founder, Eddie, who worked at Mozilla and was involved in Rust, said, well, we could use Rust. And I was like, it compiles to WebAssembly. So that dream of mine that it would run in a browser could still be done. So then I retrained myself in Rust, and that was hard.
So how does Makepad leverage the power of the modern CPUs and GPUs to enhance performance?
I'm sorry?
How does Makepad leverage the power of modern CPUs and GPUs?
So, because Rust is compiled, and I try to write the code for the UI model for Makepad is relatively efficient, and it's mostly very simple, and that means that it mostly doesn't use your CPU, right? I got back to the 1 millisecond per 16 or whatever, 8. I got back to that 10% of CPU use so that you can use the CPU for something useful or that it doesn't drain your battery, right? Or your laptop or whatever. And for the GPU, because I offloaded a lot of the styling to little shader programs, that means that you don't need to run a vector engine triangulator or vector engine code on the CPU, so that saves time. But it has to be said, the GPU part is a little bit less efficient than if you feed it very simple or very generated vector data with a very simple shader. So the GPU compute gets a bit less efficient with Makepad, but I think that is a trade-off worth it because yeah, in a way, if you don't repaint all the time, then your GPU won't drain your battery either. And also GPUs are getting faster and faster. So even within the window of GPUs, my GPU time use is also shrinking. So that's a matter of time. When I started Makepad, I was worried that I was using too much GPU. But now I think we're reaching the point that it doesn't matter that much anymore.
See. So does Makepad has any unique approaches to handling cross-platform development?
First of all, one of the things that may be a bit unique is that Makepad actually doesn't try to abstract the platform too much. So it is a high-level platform abstraction. And the reason I did that is because low-level platform abstractions are very difficult to align because platforms are very different. If you look at the backend implementations of Makepad, we have WebAssembly, we have iOS, we have macOS, we have Windows and Linux, and Android. And if you look at the implementation, they have some similar shapes, but like the event loop is completely different. On Android, we even run in a special thread, not in the UI thread, and so on. Like the graphics APIs are also not. They're also high level abstracted. They're abstracted at the level of the shader compiler that generates from our Makepad shader language to Metal or to GLSO. And then I just have a scene graph interpreter per backend, so you don't have to make. Another approach would be like WGPU, right? That is a low-level platform abstraction. And low-level platform abstractions tend to be very, very complex. So I thought that was out of scope for Makepad, and also WebAssembly is even completely weirder. It's a message passing based backend. So yeah, low-level there would just not even be performant. I do think, of course, I think WGPU is amazing and we might use it, but this approach for high-level platform abstraction gave another advantage to Makepad, and that's its compile time. Because we have everything from the platform layer on up in our code base, I have almost no dependencies on external crates, especially not for platform layer, and that means that on my MacBook, I can compile Makepad Studio, our IDE, with all the widgets, all the stuff from a clean build in 10 seconds. And so if you add WGPU, then you can go make a coffee or something. It's not something I'm looking forward to add those dependencies. So I'm going to try to stay lean as long as I can. And I think even now with our font support, we're getting quite close to being complete without actually having had to pull in all that baggage. And we'll see if it lasts, but I always say that you can only begin with a fast compile, because in the end you don't know. But if you don't begin with a fast compile, you most definitely won't have it at the end.
I see. So how do you see Makepad competing or collaborating with other popular UI frameworks like Rik or Flutter or something else?
So I always set out to build a holistic vision, not just a framework. I want to have the whole IDE with Visual Designer, with Code Editor, all working together in a very nicely tuned way, so that you can give a developer, either or not assisted by AI, the application, and then you can just drag and drop and design your application together, push a button, and then deploy it to a phone, the web, or to desktop. And I think that that holistic approach is the way we're going to differentiate, because I don't think Flutter has a design tool, or maybe some people have a Flutter design tool. What is it? Web definitely never really got one that worked. I mean, of course, people have tried. Webflow is one of them. So, as for cooperation on the web, Makepad uses a web canvas, so you can embed it in other applications if you want to. On other operating systems, it's not that cooperative because it has its own metal window, right? This is also why we do want an optional WGPU backend, because that would allow, for instance, interoperability with Bevy and these kinds of things. But these are not on the top of my priority list, because I first want to get to the value that we set out to build before I get distracted in building all these compatibilities with other systems.
So, looking ahead, what's our plans or vision for the future development of Makepad?
So, as I also said in my talk, I think the old ways are going away. The old ways of software development are right at a turning point in terms of AI to change significantly. And that means that the old way of redoing Visual Basic for Rust is not going to be enough for Makepad moving forward. And so we re-envisioned a little bit like, okay, what is the role that Makepad can play in this new AI future where we have AI agents, where we have AI assisted programming, AI assisted design. And I think there's an opportunity for us to be, at least for a while, be the interface that the developer uses to put together applications working with an AI. So the vision I have is that there's new multimodal, also open source AI models coming online that also can see, right? So what would be nice if you have an IDE where you can have an AI generate a UI, but then also see the result. And if it did what the AI expected to generate, and if it didn't, it can automatically regenerate and correct itself visually, right? That seems like a very interesting angle, because then you don't have to be in the loop again, like, okay, that button didn't make it in, so could you please put it in? No, I can see that himself or itself. And then also you can loop in compiler errors from Rust. I think because Rust has such nice errors, it might be that Rust is going to be the nicest language for an AI to operate in, because you get so much compiler information, type information goes in from Rust Analyzer and the code editor, and then out comes a beautiful error, what it did wrong. And then that's a thesis, right? I haven't proven it, I don't know if it's actually true, but this is what we're going to go explore, like see if, because we have this IDE with like live compiling and live design, I think slotting in an AI in a very productive way is an opportunity for us. And not just an opportunity, it's a requirement, because this is how software development is going to work in the near future, and yeah, you either do it or you're no longer relevant, I think.
Yeah. So can you elaborate on the AI integration you just showing this morning? Yeah, the thing you demonstrated with Makepad, AI with Makepad. So what specific AI capabilities have you incorporated?
It was really the first AI integration that I've done. It is very or the first language model. It is very simple. I have a set of examples that I wrote with comments. I pass that in the context, and I pass in what you ask of the AI, and then every time it made a mistake, I made a line correcting that mistake, like don't do this, do that, don't do this, do that. And I add that into the context as well. And that turned out to work well enough that it would generate both our shader language and UI DSL and Rust APIs good enough but yeah, time will tell how far that scales. I just don't know yet. I just wanted this proof of concept to be in my talk.
So what inspired you to incorporate AI into Makepad? What comes out when this comes out in your mind? So was this always part of your vision, or did it involve some recently?
No, it evolved recently. As I said, I've been doing this for now 10 years, and it is the result of me doing Cloud9 and having all these engineering challenges in the front end that I couldn't solve. It took a bit longer than I hoped because I had to abandon JavaScript, I had to learn a new language, Rust, and I had to evolve the whole system. If you look at Makepad 6 months after I started Rust versus now, it's completely different, right? It has evolved like 3 or 4 times. But different from JavaScript, you can actually evolve Rust. You can actually refactor Rust because the compiler is so nice and so good at telling you stuff. If you refactor JavaScript, it's really hard because you break all sorts of stuff that you're going to find out at runtime. It's terrible. It's a terrible experience. So Rust is already a big improvement there for my own workflow. So I don't really have had a timeline where I'm like, oh, I need this to be done at this time. I'm developing in a direction, right? But time also changes around you. So when I noticed AI code generation, I started to go like, okay, how does this fit in? How does this work? But early experiments, like just a year or two ago, like, nah, it doesn't generate our syntax and it makes too many errors to be useful. But recently, when O1 was released, I started to see that it was actually generating really good code. And then I also started investigating the open models again and realized that the open models actually weren't that far off anymore, right? They were getting closer and closer. And another thing is that Makepad, I think, at least when I ask these AI models from everybody, like, hey, do you know Makepad? And they go like, yeah, it's this and that, and it works like this and this. And I'm like, okay. So we're apparently in the training set. And I think that also makes a big difference because the AI already has read our code base and is trained on it. So that I think, so only a few weeks ago it clicked and was able to do it.
Yeah, you just mentioned O1, so then let me remind, last week I have announced a paper said LLM really can't reasoning planning or something like that. And you tweet that finally we don't need to say please to AI models. Yeah, actually just until this afternoon I'm still saying please to AI models.
I do too, I do too. It's just, I even think that it might give a better answer because of it's so trained on human context.
Yeah.
But I don't know, I don't have proof for that. I just find it rude to not say please. So it was a joke.
Yeah, I know. So you think we need really AI can reasoning with human heart or something like that. So from a programmer perspective, you think we need a robot with human heart, or we just need a tool? We need a perfect tool.
I find it hard to say what we need. I think this is going to be a wild ride for everybody, and we're going to have all the variations of all the things. We're going to have computers that appear to have a heart. We're going to have computers that are assistants. We're going to have everything, and it's not something I can control or steer. It's like this. There's a wave coming, and all you can do is try to navigate it and surf it.
I see. So back to Makepad. How does the integration of AI enhance Makepad's user functionality for developers?
How does it enhance?
How does the integration of AI enhance Makepad's functionality for developers?
So when you make a new framework in a new language, right? Rust is new. For a lot of people it's new, right? And you will introduce a new DSL for UI description that uses shaders. There are a lot of unknowns. So either you need very good documentation, and then you also need someone willing to read that documentation, which is getting more and more rare nowadays, to use your system, or you find a way that the AI can do the boilerplate, can you just ask it a question and it gives you hopefully a working answer because it read the docs for you. it read your examples for you. And I think for Makepad as a new framework, the AI integration is probably what can make it succeed, whereas before it might not even have succeeded.
I see. So how do you see the combination of Makepad's performance-focused design and AI impacting application development?
So my hope is that because we can now use AI to generate Rust from a higher level, I don't know, specification or narratives or sketches, that the performance benefits of Makepad, which come from the use of Rust, will be much more accessible. Right, like Rust is not an easy language to write. It has a borrow checker, which for people that understand only a garbage collector, it's very, very difficult. And so my hope is that this will actually enable the performance enhancements that we have without making it too hard for the developer.
Yeah. For those doubtful developers still considering using Makepad, so what improvements to their workflow do you think it can bring?
So a lot of those improvements are still in our future. Makepad is good enough to build. We have the example application like Robrix, the Matrix client that Kevin is building, and Motion, the AI front end application. These are also very good test cases for our UI systems, but they're also built by very skilled developers. And because building a UI like an IDE is still quite hard if you look at the logic required, right? It's not a pizza ordering app or something. So but we're using that infrastructure now to build out the tooling. Like we don't have the drag and drop editor ready for someone to use yet. It's in progress. We don't have the type information integration in the IDE. All of these things are in progress. So I would say we're aiming to get this into developers' hands as really like in next year. Mm-hmm. But you can definitely play around with it and have a look and talk to us on Discord.
I see. Yeah, I have once heard about all the programmers have a little bit or many of the self-doubt. So after AI come up, so will that self-doubt will be more stronger, or have you ever have self-doubt, and have you ever have advice to the programmer that have self-doubt?
I think every time one of my JavaScript experiments failed, that was not a happy moment, right? Yeah. But then I took all the learnings from that phase and try again. Yeah. So self-doubt should not be a moment where you give up, but where you use your learnings or what you what went wrong and just try again. And I think the self-doubt is actually not having self-doubt is actually is a less good situation because it stops you from reflecting and learning. Yeah. So I would not be afraid of it, but like embrace it. But don't let it paralyze you. But use it to make a better informed decision for the next thing you try.
I see. So the last question, phase two, for the old programmer phase two, the AI era, and all the developers who want to start using Makepad or contribute to the projects. So what words or advice would you give to them?
What do you mean by old programmers? Is like senior programmers? Is that what you mean, or?
Old programmers facing to the AI era, I think.
Yeah. So. I'm facing the AI era as well, right? Like everybody is. Yeah. And so I had a lot of reflection also on Twitter. I was bouncing ideas like how should I think about this? How can I turn what is coming into a positive aspect, right? And so I realized that first of all, you can't ignore it, right? If you ignore it, then you will not gain the tremendous productivity advances that are coming. They're not there yet fully, but they're already coming. And a lot of developers are also already using Cursor or using AI-assisted documentation search or writing comments, or it's already happening for them, right? But I would say you can't ignore it, so you have to embrace it, and not just embrace it, but there is a period coming now where instead of needing an expert developer or a junior to do boilerplate work, you can ask the AI to do that. So for a lot of developers, we're going to have a period of superpowers at our disposal to make what we want to make. And I think that my most positive view on it is that we better enjoy that period that is coming.
Yeah. So thanks for your words, Rik. And thank you, Rik, for the insightful discussion. And thanks to all the developers watching. So that's all for today's podcast. So see you next time.